BCA-101. This Introduction to Computers and Information Systems, week 14, Thursday, Information Systems and Database. So we listened to a little bit of a podcast from NPR, talked about big data. We talked about these huge sources of data and how we analyze them. And we talked about how we went using software and algorithms to find just the data we need, like a certain chart that would show us some tendency so that we can make decisions based on the data. Okay? Then today, we started with the top-down design, development of an information system. First thing we talk about life cycles. Information systems go through life cycles just like humans do, or pets, or your car, or lots of things that we get and we last a certain amount of time. We initiate them, we create them, they're productive for a certain amount of time, then they get to the point to where they are not productive anymore. Could be anything. So here we're going to talk about information systems. So we got these steps to develop an information system. We're going to do the top-down design first. We have investigation. You have to define the problem. You have to understand the problem. Then you have to analyze the situations around that problem or how they currently work. We used example, NIAC used to use POISE to manage the students and the faculty, and it was the database that kept all that information in, which courses there were, which courses you're going to take. Well, there was a problem with POISE. It was getting old, it was getting hard to maintain, maybe we couldn't maintain it at all, plus it didn't allow us an easy way to communicate with it from the web. So then they started looking at a package called WebAdvisor. And in the steps then, they would analyze what we want to do here at the college, okay, how the current system works. You can go ahead and use that. How the current system works and how the data flows and how do we improve to solve the problem. So we analyzed that, and they looked at some different options. Then they looked at designing what they needed, kind of like looking for a solution. A good example would be, a problem is you need a new place to live. We gave a variety of reasons why you might need a new place to live, so you understand the problem. Maybe your family's growing out of your current place, and so you analyze, you decide, well, can we buy, can we rent, apartment, house, whatever. So you analyze it entirely and figure out, let's say you think that you can buy. So then you start designing a solution. You can say in your analysis, say, well, we really need 2 bathrooms or 3, and 3 bedrooms, and et cetera, et cetera. We need room for the kids to play, so we need a play area like a big basement or a big family room, et cetera, et cetera. Then finally, when you get the analysis done, you got to figure it out about how much it might cost, and can we afford it, will it be worth it, et cetera, et cetera. Then you can start designing. The design is a solution to our problem. We need a house, or we need a new information system to manage students. Okay?
Is it both the assignment and project is tomorrow night?
Moving next week. So, then you design a solution. It'd be like the blueprints for a house, okay? As an example. You design it, which is a lot of work. These little circles here means you get lots of feedback. You do some work, you see if it's good, make some changes, do some work. Then eventually, we talk about data flow diagrams for an information system. Then eventually you're going to develop your new system. You're going to buy the hardware, and you're going to get the software. And you're going to make sure you test it well before you implement it. In terms of the software, you might look for packages that are close, that you can purchase, or maybe adjust to match your needs, or you might have to create your own. Create your own software to do your particular task, which would be programming. That typically is way more expensive than purchasing a package. Some packages allow you to do some programming on your own within the package. Okay? So you write it, you design it, you put the system together, you do lots of testing based on data you figured out you needed to do with the analysis. Then eventually, when you feel like it's ready to go, you can take it and you can implement it. You can try it like in one area to see if it works, or you can phase it in different parts of it at a time. That's the way WebAdvisor was done, or direct cutover. Just quit the old system, put in the new. Sometimes you can only do a direct cutover. A lot of times, some cases, like you might have one store, you can put the information system in and see how it works. If it works well there, then you can put it the rest of the stores. Last step, evaluation, and then how well you maintain it, or how you would maintain it. Evaluation takes you back up to where you investigate if you're having any problems with it. You check your analysis to see if it's actually doing what you want it to do. And if you need to change or adjust something, you design the new solution, you develop it, you implement it. A lot of times in software that's called a patch. You implement the new patch, and then you evaluate again and make sure it's working. All right? So, an information system. This is a top-down design. The last thing I'll mention. Bottom-up design, that would be where you would quickly do your investigation, analysis, a little bit of design, and then you develop it right away. You develop something, it's not the total solution, then you work your way back up a little bit, do some analysis on that, redesign, adjust it. Sometimes it's implemented almost right away. So often referred to as rapid prototyping. You get a prototype up and running, and you see how that works, and then you make adjustments to it as you go. That works good in some cases, like a good example would be spreadsheets. You can start a spreadsheet and make adjustments to it and redesign it as you go, or maybe your PowerPoints. You can start, rearrange, and work on them. Those things work well, and some small information systems might work well using a bottom-up approach because it's much faster. You get a working solution much sooner. In some cases, like if you're designing software to solve the problem of landing airplanes at a big airport, well, you can't rapid prototype that or bottom up, because if you make one mistake in the design, it could be disastrous. Whereas here, the top down, you make sure each of these levels is correct before you move on to the next. Okay, so the software will be much more reliable in terms of how it works. So I'll get a shot of the entire board. You can ignore what's in the purple. And we talked about big data, and that would be it.